Let's draw an isosceles triangle. It's a triangle in which two of the sides are equal to each other. And we had seen in the previous video that it has a vertical axis of symmetry. If this part is flipped to the other side, we see that the two parts match exactly. And that's why we say that this shape is symmetrical. This is called reflection symmetry. Why is it called that? Let's see. If we take one part and keep it against a mirror, we will get the original shape. The reflection of one part completes the shape. But wait, what is the other kind of symmetry? Do we have another kind? To know the answer, here's another figure for you. This figure is made up of 6 squares to be precise. Now I want you to tell me if this shape has reflection symmetry or not. Can we draw a line through it such that the two parts formed match exactly with each other? If we try out different lines, we realize that no such line can be drawn. This shape has no reflection symmetry, but what this shape has is rotational symmetry. Yes, rotational symmetry. What does that mean? As the name suggests, let's try rotating the figure about its center point. And what does rotating about a center point mean? Take the example of this triangle. If we rotate it about its center point, it will rotate like this. If we rotate it about this point, it will rotate like this. And if we rotate it about one of its vertices, it will rotate like this. The shape will rotate differently depending on the point around which it is rotated. Now let's come back to our figure. We rotate the figure completely around the center point once and see how many times it looks exactly like the original one. Rotating it completely means rotating it by 360 degrees. Let's have a counter on the right which counts the number of times the rotated figure looks like the original. Let's start. Now the figure rests at 0 degrees. After rotating it by 90 degrees, we get this shape. It's not the same as the original. The counter is still at 0. Okay, so let's rotate the original shape by 180 degrees. And we see that it looks exactly like the original shape. It fits in perfectly. We see an increment of 1 on the counter. We continue rotating it till we finish one complete rotation. Rotating it by 270 degrees gives us the shape which is not the same as the original. And rotating it by 360 degrees gives us the original shape back. The counter changes to 2. What does this 2 tell us? It tells us that when this figure is rotated completely by 360 degrees, the rotated image looks exactly like the original image twice. Once at 180 degrees and another at 360 degrees. So we say that this shape has rotational symmetry of order 2. To recap, when do we say that a shape has rotational symmetry? Okay, this is long, so I want you to listen to it carefully. A shape has rotational symmetry if it looks exactly like the original shape a number of times when rotated about the center point by 360 degrees. Here, the number of times it looks like the original is 2. So we say that this shape has rotational symmetry of order 2. Is it easy to find the order of rotational symmetry? Let me give you a few shapes, and why don't you try finding their order of rotational symmetry? First, an oval looks like this. Next, a square, an equilateral triangle, and a circle. Each of them has rotational symmetry, but we need to find the order. We begin with the oval shape and start rotating it. Let's see how many times the rotated image looks like the original. Once and twice. We saw that it looks like the original shape 2 times after the complete rotation. Its order of rotational symmetry is 2. In a similar way, why don't you try finding the order of rotational symmetry for these 3 shapes? Let's start rotating the square now about its center point. 90 degrees, 180 degrees, 270 degrees and 360 degrees. Clearly, the order of rotational symmetry for a square is 4. Now for the equilateral triangle. 120 degrees, at 240 degrees, and at 360 degrees. 3 times in one complete rotation. The order is 3. And now we come to the circle. What do you think will be the answer here? No matter how we rotate the circle, it will always match the original shape. It will have rotational symmetry of order infinity. So remember, a shape has rotational symmetry if it looks exactly like the original shape a number of times when rotated about the center point by 360 degrees.